Welcome back to the deep dive. So you sent over this incredibly detailed data set. It's labeled TOYWEAPONTOOLZ 16A GRIPZ. And our mission today is really to just reverse engineer the logic here.
Yeah.
Because on the surface, okay, it looks like an instruction manual, but the engineering underneath it's intense.
It really is. I mean, we're looking at a complete coded configuration system that uses just 4 digits of binary information.
Just 4 bits.
Just 4 bits to define 16 distinct biomechanically precise hand grips. The real question is, how does it do that? How do you turn 4 simple choices into 16 totally different ways to hold something?
And with risk assessments built right in.
Exactly.
Okay, so let's unpack the geometry first. The core definition, it seems to rely on assigning a function to the knuckles and the thumb, right? For both hands.
Right, independently. And the choices for each are binary. For the knuckles, it's either blocking or blade.
So blocking is kind of what it sounds like, a closed defensive posture.
Yeah, think of it as compact, designed to absorb impact. Blade, on the other hand, that implies the knuckles are extended. You're prioritizing leverage, maybe force application.
Like for striking or cutting.
Exactly. And the thumb has a similar binary choice, Pommel or Hilt.
So let's look at the extremes to see the range here. We have the piercer, which is just 0, 0, 0, 0.
Right.
That means it's mandating a completely defensive stance. Both hands are knuckles blocking and thumb pommel. It's all about structural integrity.
Now you compare that to Scathe, which is 11-11, the complete opposite.
Ugh.
Both hands flip to maximum offensive potential. So you have knuckles blade and thumb hilt. And what's wild is that the entire mechanical disposition of the grip, from pure defense to pure offense, is mapped by those 4 bits.
But that's just the geometry. That's only half the story. The system also introduces these structural variables, AxisBias and HandMode.
This is where we go from what the hands are doing to what the body is trying to do. AxisBias, you see it as A, B, or AB. It seems to categorize the structural load.
So like the torque.
You could think of it that way. Axis A seems to be a more vertical, balanced alignment. Axis B, on the other hand, it seems to introduce a lateral force, a rotational twist.
And then there's the hand mode. It uses those Greek letters, phi.
Right, the lowercase phi and uppercase phi. Lowercase phi, that signifies LeftLead. Uppercase is RightLead.
Okay, that felt a little counterintuitive to me at first, because purely defensive grips like piercer and estosh, they're often left-led. You'd think the right hand would be dominant.
I think it's fascinating here is that the system isn't using lead to mean power. It seems to mean structural initiation. So a left-led, a phi grip, it's designed to manage the flow of an interaction, maintain distance,
Which is key for defense.
Exactly. Whereas a right-led, the uppercase phi, like you see in Pike and Scathe, well, that's all about maximizing offensive output along one line of force.
Which brings us to stability. This is where it gets really interesting. It maps risk using 4 color-coded anchor points. Blue E3, green 9, red 2, and orange 8.
Think of them like pressure gauges. These 4 points are always there, geometrically, but the system categorizes them as either stable anchors or risk anchors, depending on the grip.
And that defines the safety profile of the whole setup.
Precisely.
So if we connect the dots, the axis bias seems directly linked to which anchors are stable. Let's go back to piercer. That's axis A.
Yep, and its stability comes from blue E3 and green 9, which are relatively centered points.
Okay, now look at Scathe again, the fully offensive one. That's axis B.
And it shifts its stable points to blue E3 and orange 8. So the insight here is that axis B, by introducing that lateral force we talked about, it makes that centered green 9 anchor a risk.
It compromises it.
It compromises it. So stability has to shift to the periphery, to orange 8, to handle that torque. The system is compensating for its own aggressive geometry.
So when we put it all together, what do we have? We've basically decoded a complete classification system for 16 hand configurations.
Defined by geometry, directional bias, and these really precisely mapped stability points.
And it just shows the rigorous engineering needed to standardize something as simple as a grip.
Well, it leads to a final sort of provocative thought, right?
Right.
Why would a system labeled toy weapon tools need this kind of high-stakes engineering logic? Binary codes, structural axes, color-coded stability maps?
Yeah, that precision, it suggests it wasn't designed for, casual play.
Not at all. It feels more like something for standardized performance, maybe safety training, or even highly specific digital modeling, something for you to mull over until our next deep dive.
Welcome to the deep dive. Today, our sources are taking us somewhere incredibly specific. We're looking at the TOYWEAPONTOOLZ Z16-time GRIPZ classification system.
Right. And this isn't just, a simple guide on how to hold something. It's more like a coded language for physical forms.
Exactly. So our mission here is to really get our heads around how this superstructured system takes the, I guess, chaos of human physicality and standardizes it.
Yeah, and it translates every single variable into cold, hard data. It's a way to score the potential of these 16 core grips.
And the fascinating part for me is the level of detail, the resolution. It's defining what the knuckles and the thumb are doing
For both the left and the right hands, simultaneously.
Which is 4 independent variables for every single grip. So, I mean, what's the mechanism? How does it even handle all that?
Well, it all boils down to a 4-bit binary code. It runs from 00000 all the way up to 1111.
And that gives you the 16 grips.
That gives you the 16 grips. But the really revolutionary thing here is that the binary isn't just an index number, It actually dictates every single physical and performance attribute.
Okay, so to get that, we have to define what the bits are controlling. What are those physical choices?
So you have 2 choices for your knuckles and 2 for your thumb. For knuckles, it can be either blocking, which is all about impact dissipation.
Maximum absorption.
Exactly. Or it can be blade, which is for maximizing edge alignment. Precision.
And the thumb.
The thumb is about leverage, so you're either on the pommel or on the hilt.
That makes the extremes really, really clear. If you take piercer, for instance, that's 00000.
Right, so that's both hands set to knuckles blocking and thumb pommel, a configuration that's just built for absorbing force. Pure stability.
And then you contrast that with the complete inverse, scathe, which is 1111.
And that's the full shift. Now both hands are knuckles, blade, and thumb hilt. So you can see how this system cleanly maps every physical choice onto that binary sequence.
So if the 4-bit code sets the physical structure, the next logical question is, how does that translate into performance? Is there a bias?
Precisely. And that's where AxisBias and HandMode come in. AxisBias can be A, B, or AB, and HandMode is either a LeftLead or a filler RightLead.
Yeah, does the binary predict that?
It does, which is fascinating. You see this clear tendency, especially with grips from Pike at 0101 and up. As you start adding more ones into the code, they almost all start to favor the filler RightLead mode.
So the system itself has a built-in preference for the dynamics that come with those grip shifts.
It seems that way, yeah.
I think the most counterintuitive part of this whole thing, where it makes its biggest intellectual leap, is the anchor concept.
Oh, absolutely. The anchors dictate the spatial stability.
Right. So you have these 4 fixed reference points in space. Let's call them 3, 4, 5, and 6. But the grip itself redefines which of those points are stable and which are risk. Why is that so important?
Because the stability isn't just about your hand position. It's about where the force is anchored in space. That shift is what matters. So, for example, grips with an A bias, like piercer.
Stable 1000.
Yeah, that one. It uses the left anchors for stability, points 3 and 5.
But then if you switch to a B bias grip, like the powerful scathe configuration,
the whole stability point pivots. Suddenly, your stable anchors are point 3 and point 6. So the binary isn't just defining posture. It's defining the grip's physical balance point in a coordinate system.
and by extension, its predicted use.
Exactly. What this TOYWEAPONTOOLZ Z system really does is create a complete coded language. Every single configuration gets a unique binary signature, and with it, a set of quantified performance biases. It's an absolute standard.
It's clear the whole system prioritizes quantifiable data over, just intuitive feel.
Yeah.
So it's something for you to chew on as you look over these classifications. Given those highly specific axis biases and lead modes, how well do you think those purely technical parameters actually define the function that's suggested by the human names? Names like shield, viper, or wall. Is there still room for interpretation, or does the data truly tell the whole story?
Okay, so let's get into the source material we've been looking at.
This index, right, the TOYWEAPONTOOLZ 16 GripZ.
Exactly. And it's this incredibly structured blueprint, 16 different postures.
16 very precise physical postures.
And our mission really is to decode the logic behind it all.
To show how you get from just 4 simple binary digits,
Yeah.
that 000 to 1111.
To these really complex and strategically named configurations.
What's amazing is how consistent the structure is for every grip.
You mean the left hand, right hand positioning? The AxisBias.
and the HandMode, and maybe most critically, the designated stable and risk anchors.
It's complete kinetic formula.
It really is.
So where do we even begin? I guess with the hands themselves, right?
That has to be the foundation. Those 4 binary digits, they're defining the 4 key contact points of your grip.
So a 0 means one thing and a 1 means something totally different.
Precisely. For the knuckles, it's a choice between blocking or blade,
And the thumb.
pommel or hilt, a very clear distinction.
Okay, so let's take the 2 extremes to see how that works. Piercer is 0, 0, 0, 0, all zeros.
Right. And what that means is both hands have their knuckles set for blocking and the thumb on the pommel.
It feels like the ultimate defensive starting point.
It's the baseline. Now flip all the switches. Go to 1111.
Which gets us to scathe.
And everything inverts. Knuckles are designated blade, thumb is on the hilt. Purely offensive.
It's a perfect binary opposition.
A perfect mirror. But then you get into the more nuanced cases.
The mixed ones.
The mixed ones. Take Viper, that's 0001.
Just that one bit flipped at the end.
And that single one changes the function of the right hand. The left hand stays defensive, blocking pommel.
But the right hand knuckles switch to blade.
Exactly. So you're primarily defensive on the left, but you're ready to cut on the right. All from one digit.
Okay, so that's the what, the hand positions. But what about the how? How does this actually impact movement?
Well, that's where AxisBias and HandMode come in. These are the operational consequences.
So AxisBias has 3 states. I see A, B, and AB.
Right. You can think of A bias as favoring, say, forward momentum, reach.
Like in Piercer and S-Dosh.
Exactly. And B bias is more about leverage, rotational stability.
For grips like row and harbor.
Mm-hmm. And then AB is the hybrid, the balanced stance that lets you transition between the two.
And HandMode is just about which hand is leading.
Essentially, yes. We have phi for LeftLead and the capital Phi for RightLead.
And there's a pattern there, too. Piercer is LeftLead.
But as you accumulate more ones in the code, the grips tend to flip.
To RightLead. No, wall, scathe, they're all RightLead.
Signaling a shift to a more offensive initiation.
It all connects. Which brings us to, I think, the most fascinating part, the stability anchors.
This is where it all ties together. You have 4 potential anchor points.
Blue E3, green and 9, red 2, and orange 8.
Right. And for every single grip, the system specifies exactly 2 stable anchors.
Which, by default, means the other 2 become your risk anchors, your weak points.
Your points of structural weakness.
Mm-hmm.
And you can see a direct relationship.
Between the bias and the anchors. Yeah, the A-bias grips, like Piercer, they anchor on blue E3 and green 9.
But if you look at the B-bias grips, like Scathe,
the stability shifts. It moves to blue E3 and orange 8.
To reinforce that rotational leverage we talked about, the bias literally dictates where you draw your kinetic strength from.
It is really amazing how much information is packed into just 4 digits.
You go from a simple binary code
to a full physical posture with an operational bias, a lead hand.
And a precise map of its stable and weak points.
Mm-hmm.
The names say it all, don't they? Shield, wall, Viper. They're strategies.
They are. So the source material gives us the grip itself and where the anchors.
It gives you the static blueprint.
Which leaves a pretty important final question for you to think about.
Yeah. If this level of specific coded classification exists just for the static hand grip, what are the unstated rules of engagement?
The rules for movement.
Exactly. What's the actual practical difference that distinguishes, say, a shield from a wall?
The difference must be in how you apply it under pressure. Something to mull over.
Welcome to the deep dive. Today we're jumping into something really fascinating, a kind of secret language for the hand.
Right. It's a highly formalized system called TOYWEAPONTOOLZ Z16 outgrip piece.
And our mission, really, is to decode this thing. It uses binary code, of all things, to classify 16 different hand positions. You're about to see how just a tiny digital change can create, well, a massive physical difference.
It's amazing how organized it is. It's almost like a programming language for your hands. Every single grip has a 4-digit grip binary code, from 0000 up to the 1111.
So those 4 digits are like the grip's DNA.
Exactly. They represent 4 states, left knuckles, left thumb, then right knuckles and right thumb.
Okay.
And for each one, a 0 means one thing and a 1 means another. For knuckles, 0 is blocking, 1 is blade. For the thumb, 0 is pommel, and 1 is hilt.
Okay, let's unpack that with the extremes, because I think that's where it really clicks. Let's start with Piercer. That's the 0 state, right? 0, 0, 0, 0, 0.
Yes, all zeros. That means you have knuckles blocking and thumb pommel in both hands.
And what does that mean functionally? What is that posture for?
It's all about pure control. The thumb pommel position is, it's relaxed, it's open, it lends itself to really stable defensive setups.
Right, and then you flip the whole thing on its head.
Flip every single digit to a 1,
Mm.
and you get scathe, which is 11-11. Now suddenly, it's knuckles, blade, and thumb hilt in both hands.
And thumb hilt is the opposite of pommel. It's locked down.
Completely. You're locking the handle down for maximum leverage. That's your high leverage, often offensive configuration.
What's really fascinating, and I saw this in the source material, is how the binary structure itself seems to dictate the user's lead hand.
Yeah, the hand mode.
Exactly. The lower codes, like Piercer or Cascade, which is 0000, they almost always use the left-lead hand mode. Why? It feels like that removes the user's choice.
Well, it connects to the inherent stability profile of those low binary combinations. They're just more stable with a left lead. But as soon as you start adding those 1 bits,
You're increasing the leverage.
you're increasing leverage and risk, and the hand mode shifts. The higher binary codes like Pike 0101 or Scathe at the very top, they're dominated by A, the right-lead hand mode.
And that also brings us to this idea of AxisBias.
Right, the way the hands align, AB or AB.
Can you just quickly clarify that? I'm seeing AB grips like Angard 00011, but then you've got these pure B grips like XXX, which is 01111. What's the practical difference there?
The axis bias is really the style of the grip. So A implies balance, central stability. B suggests more of a rotational bias, and AB is, a mix of the two.
I see. So the digital DNA defines the grip, and the axis bias defines the style.
And that DNA translates to physical pressure points, which brings us to the anchors.
These have the most cryptic names: FLB3, BLG5, FR2, BR06. What are we actually talking about with these labels?
They're anatomical zones. They're not just random codes. You can think of F as finger, B as base, and the number is pointing to a specific joint or metacarpal. And these 4 specific locations, they serve as both stable anchors and risk anchors, which is the really interesting part. It all depends on the grip you're in.
What's so surprising is how a change doesn't always lead to a physical shift. Take Piercer 1000 and Shield, which is 1000.
Right.
Shield just changes 1 digit. The left thumb goes from Pommel to Hilt. That changes the grip name entirely. But they share the exact same stable anchors, FLB3 and BLG5.
Yeah, and that's because they're both categorized under the A axis bias. That A bias prioritizes core stability along that specific plane so the anchors stay put.
But they don't always stay put.
No, not at all. You look at an AB grip, like Angard, and the stable points shift to FLB3 and FR2. Then you go all the way to a B axis bias grip, like Scathe, and they shift again to FLB3 and BR06. The stability profile is literally following the function.
So if I'm tracking this correctly, the system gets this incredible depth from tiny changes. You switch one thumb's roll, and you could instantly change the grip name, the lead hand, the axis bias, and the entire physical anchor setup.
Precisely. And that leaves us with, I think, a really interesting final thought.
Yeah.
The system uses the same 4 points, FLB3, BLG5, FR2, and BR06 for everything. They're used as stable anchors in some grips and risk anchors in others.
So the point itself isn't inherently stable or risky.
Exactly. So the real question is, does the context of the grip itself, not the physical location, dictate whether an anatomical point represents stability or vulnerability? It makes you think about how the goal of your action fundamentally redefines the physics of your own hand. Welcome to the deep dive. Today we're jumping into a really fascinating and proprietary system.
It's called TOYWEAPONTOOLZ Z16AGZ.
Right. And our mission here is to basically decode it.
To figure out how it takes these super complex physical postures or, tool engagements and boils them all down.
All the way down to a simple 4-digit binary code. It seems almost too simple.
Well, that's the elegance of it. It's binary logic applied to physical reality. We're looking at 16 specific positions, these grips, with names like Piercer, Viper, and Scathe.
And each one gets a unique 4-digit grip binary.
Exactly. And that code is built from just 2 essential binary states for both the left hand and the right hand.
So just 2 characteristics per hand. First, for the knuckles, are they blocking or are they blade?
And then for the thumb, is it Pommel or Hilt? That's it.
Okay, let's ground this for everyone listening. What does it actually mean if your knuckles are defined as blade? What does that indicate?
It's basically a proxy for intent. So if the knuckles are blocking, the posture's defensive. You're absorbing force or you're creating a stable structure.
Okay.
But when they flip to blade, it implies the hand is set up to strike, to slice, or, project force outward. It's an aggressive operational state.
That context makes all the difference. So if we look at the baseline group, Piercer, Its code is 00000.
Which makes perfect sense.
Both hands are knuckles blocking and thumb pommel. It's symmetric, it's defensive, it's the foundation.
Right. So now let's flip to the other operational extreme.
The maximum aggression.
Exactly. If piercer is 000, then you get scathe at 1111. Every single variable is flipped. Both hands are now knuckles blade and thumb hilt.
So the system uses a total binary flip to go from pure defense to pure offense.
It's that clear.
And that leads right into this idea of hand mode, which tells us which hand is in the lead. So Viller's for LeftLead, Viller for RightLead.
Yes, the lead hand.
And I noticed a pattern in the source. Piercer and the other lower code grips tend to be LeftLead. But once you get to the higher, more complex codes, it seems to shift almost completely to RightLead.
That's a really key observation. Increased binary complexity, more ones in the code, often correlates with a higher operational focus. And that focus tends to shift to the RightLead to the filigus.
But the real test of coordination comes next.
Yes. The next layer, AxisBias.
A, B, or AB. And this isn't about stability, right? It's about something else.
It's about the required physical symmetry. Or lack of it.
Let's try to unpack that. Take S-Touch. The code is 01 Endrid.
Okay.
It's classified as AxisBias A, but its definition looks asymmetric. You've got knuckles blade on the left, but knuckles blocking on the right. How is that AxisBias A?
Because AxisBias A means the grip is designed for a bilateral symmetry of load, of pressure. Even if the hands are doing different things, your body is supporting the position in an even, balanced way.
Ah, so it's easy to maintain.
It is. But now look what happens if we make just one tiny change.
From S-Touch at 0100 to Pike at 0101.
Right. That one little flip.
And suddenly, the AxisBias jumps from A all the way to AB. What is forcing that huge jump in complexity?
That AB tells you the grip is no longer bilaterally balanced. The load profile is now completely different between the left and right sides.
All from one binary digit changing.
And it forces a much more complex coordination, the AB, just to keep the whole structure coherent. You have to work so much harder to hold pike than you do S-Touch.
That brings us to the final and maybe most critical layer, the anchors.
The operational security check.
Every grip has to define its stable anchors and its risk anchors, and the points are blue E3, green 9, red 2, and orange 8.
And there's a clear logic here, too. For all those grips that have that clean bilateral load, the AxisBias A grips like Piercer and Viper, the stable anchors are always the same.
Blue E3 and green 9.
Consistently. The stability points are standardized for that type of symmetric coordination.
But when the complexity shifts to AxisBias B-like with the most aggressive grip, scathe or wall, the whole foundation changes.
It has to. The system demands a fundamental change in how that grip is rooted. Grips with AxisBias B, these asymmetrical or high aggression stances, they shift their stable anchors.
To blue E3 and orange 8.
Geishri. It means the stability needed for that kind of aggressive action is found in a totally different configuration. It's a quick, clear check on whether the position is even viable.
So what this all means for you, listening, is you've just seen how a system can take an incredibly complex physical stance and use this minimal, really elegant set of binary codes to give you an instant analysis.
Yeah, an analysis of the coordination, the stability, and the risk. It's like a shortcut to the operational DNA of any position.
Which leaves us with a final thought for you to chew on.
We saw that the scathe grip, defined by maximum binary aggression at 1111, still fundamentally relies on two stable anchors, blue E3 and orange 8.
It still needs a foundation.
So if the most aggressive action in this entire system still requires that kind of foundational stability, what does that tell you about the prerequisite for any high-risk action, no matter what the context is?
It seems every volatile move has to be firmly rooted.
Okay, so today we are cracking open something a little wild. It's this incredibly dense matrix called TOYWEAPONTOOLZ Z 16 GRIPZ.
It looks intense, doesn't it? Like some kind of lost engineering doc.
Exactly. And our mission really is to treat this like a biomechanical cheat sheet. We want to decode how just 4 tiny choices can change everything.
And the efficiency of it is what's so fascinating. Every single one of these 16 grips, they're just binary codes from 00000 to 1111.
And it all comes down to 4 inputs.
Just 4. It's split between your left and right hands. For each hand, you've got 2 choices for your knuckles and 2 for your thumb.
So what are the choices? I see terms like blade and blocking.
Right. So knuckles blade means your wrist is extended. Think maximum reach, maximum leverage. Knuckles blocking is the opposite. The hand is tight, compact. It's built to absorb impact.
Got it. And the thumb? Pommel versus Hilt.
The thumb is what locks it all in. Thumb hilt is your power grip. full force. Thumb pommel is more for finesse, for rapid rotation right at the end of the tool. And those 4 decisions dictate your 2 main outputs, the AxisBias and the HandMode.
Okay, so let's get into those outputs. We've got AxisBias A, B or AB, and then HandMode, which is what, this phi symbol?
Yeah, lowercase phi is LeftLead, and the uppercase phi is RightLead.
And the AxisBias, what does that actually do for the person using it?
It's all about the direction of force stabilization. So AxisBias A is primarily defensive. It's perfect for stabilizing against, say, a side load.
Which is why you see it paired with LeftLead so often. It protects the dominant side.
Exactly. And AxisBias B, on the other hand, that's all about stabilizing for vertical explosive output. It's for striking.
And as I was looking through the source material, I mean, there's a huge pattern here. The higher you go into binary codes.
It locks you into right side dominance. Completely. Once you get up to grips like knack, row, harbor, scathe, that's 1100 and up, they are all RightLead every time.
And their AxisBias is always B or AB.
The aggressive ones.
It has to be. You've committed everything to leverage and power, so your stability profile has to change to match.
Let's contrast the extremes to make it concrete. Piercer is 0, 0, 0, 0. That's the baseline.
The absolute baseline. Knuckles blocking, thumb pommel on both hands. It's compact, it's defensive.
And it gives you that AxisBias A LeftLead mode.
Right. Now flip every single one of those inputs. You get scathe, 1111.
The maximum configuration.
Total commitment. Knuckles blade, thumb hilt on both hands. Now you're in the aggressive AxisBias B RightLead mode.
But the table gives us more than that. The real story seems to be in these, the stable anchors and the risk anchors.
That's where the predictive power comes in. These codes, like FLB3 or FRR2, they aren't just points of contact.
They're what? Weak points and strong points.
Basically, yeah. The 2 stable anchors are where the system manages load perfectly. It's your structural integrity. The 2 risk anchors, like BR06, that's your weakest link. That's the geometry that's going to fail first if you push it too hard. Okay, this is where it got really interesting for me. Because the mapping isn't just, it's not linear. You take the in-guard grip, that's 0, 0, 11, and it's pretty close to the baseline piercer.
Right.
But it shares its 2 stable anchors, FLB3 and FRR2, with a really complex grip like, ooh, which is 10-10, how? Their hand positions are totally different.
That paradox is the whole point of the document. It tells you the system isn't just additive, it's weighted.
Meaning some inputs matter more than others.
Precisely. The fact they share identical stability outcomes despite having different knuckle positions tells you something. It means that the left thumb's position, whether it's on the pommel or the hilt, carries this huge outsized weight in deciding where the structural load goes. It's a non-obvious result.
So we've just mapped a 16-point system, and it all comes from 4 simple on-off switches. It defines everything from dominance to, well, to the literal breaking points of the system.
It does. Which leaves a pretty big question for you to think about. If every tiny change in your hand, I mean, just switching one thumb from pommel to hilt, like the difference between cascade and piercer, if that immediately shifts your entire balance of risk and stability, what subtle habits are you already using every single day? When you hold a steering wheel or a hammer or even your phone, how many of them unknowingly follow these exact same highly structured principles? Okay, so for today's deep dive, we're looking at a source document that does something, well, something pretty remarkable.
It really does. It takes an idea as messy and, as fundamentally human as physical posture.
And it translates it into pure executable logic. We're talking about the system known as TOYWEAPONTOOLZ 16i GripE.
And what's so fascinating isn't just that they codified it, but why?
Right.
By defining a posture with just 4 binary choices, a simple 4-digit code from 00000 to 11, you just eliminate all potential ambiguity. It's a language built for speed.
And the inputs are so minimalist, you're just dealing with 4 variables, 2 for your left hand, 2 for your right.
Exactly. For each hand, it's just a choice between knuckles blocking or knuckles blade and thumb pommel or thumb hilt.
Okay, let's just quickly define those. What are the actual physical differences we're talking about?
Sure. So think of knuckles blocking as presenting the flat of your fist. It's for absorption, for deflection.
Defensive.
Right. Whereas knuckles blade is this subtle rotation to present the hard edge. It's the offensive choice.
And the thumb?
Same idea. Thumb pommel is for stability, back at the heel of the hand, while thumb hilt is aggressive. It suggests your hand is locked down, ready for leverage.
So it gets us the basic vocabulary. If we want to understand the system's full range, looking at the extremes seems like the best place to start.
It is. We should start as 0000, which is the grip called piercer.
The absolute baseline.
It's the baseline, purely defensive. Left and right hands are both using knuckles blocking and thumb pommel. The system calls this AxisBias a sort of forward-centered alignment and left-led.
Okay, so if 0000 is maximum defense, then I'm guessing the other extreme, 1111, is maximum offense.
You'd be right. That's scathe. It flips every single variable, knuckles blade, thumb hilt for both hands.
And that must change the global parameters too.
It does, immediately. You shift from AxisBias A to AxisBias B, which is a more rearward aggressive alignment, and you go from left-led to right-led. A completely different orientation.
It all sounds incredibly rigid, though. I mean, what if you shift your thumb just a little? Does the whole code just break down?
Well, that rigidity is the entire point. It's about enforcing measurable consistency. But the system does capture nuance. It's not just extremes.
So what about a mixed grip?
A perfect example is InGuard, which is 000. Here you see this brilliant tactical asymmetry. The left hand stays defensive. That's the 00.
Okay.
But the right hand goes fully offensive, the 11.
And here's where it gets really interesting, right? Because that blending of postures doesn't just stay in the hands, it shifts the whole system's core stability.
Precisely. The AxisBias is forced into a middle ground, AB, a balanced alignment, but it's still holding that left-led orientation from the defensive side.
So the code tells you the hand position, but the secondary variables, the AxisBias and the HandMode, tell you where the body's energy is actually focused.
Exactly. And that focus leads us to the final, really critical layer in this manual, the anchor system.
The color-coded stability assessment.
Yes, and this is crucial for any kind of risk assessment. Every single one of the 16 grips gets 2 stable anchors and 2 risk anchors.
And these are drawn from a set, blue E3, green 9, red 2, and orange 8.
Which gives you this clear, color-coded metric for where a posture is strong and, just as importantly, where it's vulnerable.
So the numbers then, the 3 or the 9, are they just identifiers? Or do they relate back to something like vector fields or angles?
They're fixed identifiers within the manual's established vector system. They define very specific stability points.
So for InGuard, the mixed grip we mentioned.
For InGuard, the stable anchors are BLUE3 and RD2. That gives the user instant feedback that those 2 points are the most resilient in that posture.
So what this really all means, the big takeaway here, is that this isn't just some list of grips. It's a complete logical language for movement.
A complete vocabulary, yeah.
Every tiny adjustment you make is instantly codified, turning the physical act into pure tactical data.
We've seen a system designed for extreme functional precision.
And that leaves us with a final thought for you to consider. What kind of environment or discipline, beyond something like simple self-defense or sport, would ever require such precise, such binary definitions for something as fundamental as a grip?
What higher-level system is this for?
Exactly. What is this incredibly rigid language designed to serve?